So here we are discussing mechanical tuning today. So in mechanical tuning, the important phenomena, whatever to know. So the important phenomena here we are mentioning, so effective capacitance and the corresponding resonant frequency. So nothing but here effective capacitance. So that is C effective as well as resonant frequency F4. So both are very important for the mechanical tuning operation for this two reflex klystron. So that is we are in mechanical tuning now. So that mechanical tuning requires effective capacitance and corresponding resonant frequency. Both are be changes. ఏ విధంగా చేంజ్ అవుతాయి? Just width of the cavity. So this width of the cavity is important. So by changing the width of the cavity, so cavity width, if the cavity width is increases, changes, if the width of the cavity changes, automatically effective capacitance and resonant frequency can be changes. So that is the main point here. So in the mechanical tuning, so that the process is simply called as mechanical tuning. And the speciality of this mechanical tuning equal to stabilization in the output power. So output power unchanged in spite of the tuning. The changes is made in the tuning, so output power never be changed. So we have to maintain the stabilization in the output power. And this mechanical tuning, that is the reflex klystron, requires approximately 20 megahertz at X band. So 20 megahertz X band and 4 gigahertz at 200 gigahertz. So these are the various frequency ranges for corresponding mechanical tuning functionalities. So in practically, some in industries are practically we have a chance, that is frequency of resonance. Frequency of resonance is adjustable by mechanically by doing the following simple methods with respect to this mechanical tuning. So number one is this mechanical tuning is adjusted simply. So mechanical adjustment of the screws posts that are called as post. So this is the one of the important consideration maintained here. So just simply by adjusting the screws, simply called post. So posts are a very important method, that is called posting. What is meant by posting is nothing but just by adjusting the screws in mechanical. And the second thing, that the frequency of resonance is mechanically adjusted such that quality factor of the cavity depends upon its tuning just by a screw or sliding position. So by proper maintaining on the screw, that is the tuning the screw or sliding the piston, So in hardware reflex klystron, so by proper adjustment of these two, so quality factor will able to depends. Similarly, current flow through the tuning elements. So we have to maintain proper current flow through these elements. Why? Because here area becomes larger with the decreasing of the quality factor. So by making all necessary arrangements, the required object will be achieved in good manner. Clear? So that the current flows through the tuning elements, and a larger resonant frequency is important. So the resonant frequency is varied because of the dielectric materials. So this frequency of resonance may also shows the effect on by adjusting the variation due to the introduction of the somewhat of dielectric materials available in the component fabrication. And there is another method. So there is the another method is there will be a wall which can be moved in or out slightly by an automatic screw and become tightening or losing or blows. So by making the wall, the wall that can be moved slightly on automatic screws. So this phenomena is also by using the mechanical tuning. So sometimes this method can be used with the permanent cavities in the reflex klystron, in which can act form of limited frequency shifting. So by making proper shifting, so we have to maintain all this mechanical tuning in proper manner. So that's why in reflex klystron, which will act as the limited frequency of the shifting. So by using this technique, we are able to calculate the mechanical tuning. So that is this mechanical tuning can also be used to change the resonant frequency. Suppose one who can wants to change the resonant frequency. Suppose one who can wants to change the resonant frequency according to our experiments. So this mechanical tuning. So this mechanical tuning is helpful to calculate the FR. There. So next slide, what are the performance characteristics of the reflex klystron? So first one is frequency. So 4 to giga. So we have the 4 to 200 gigahertz. So we have the frequency range. So what is the output power? What is the output power for reflex klystron? So we have 1 milliwatt to 2.5 watts. So we solved already in previous case, that is 22.7. Clear? So 22.78, which is the efficiency. The practical efficiency maybe take one value, it may be take two value. So practical efficiency approximately 10 to 20%. Okay. So tuning range. So at 5 gigahertz, so we have 2 watts of tuning. Similarly, at 30 gigahertz, we have 10 milliwatt. So these are called a frequency range performance characteristics of the reflex klystron. So this slide indicates final brief conclusion about the reflex klystron performance characteristics. Now, what are the applications of these? So, first application. So, we are having in radar receivers. So, very popular in radar receivers while making telemetry tracking, attitude control system. Clear? So in all this one, it is used as radar receivers. First application of the reflex klystron is in radar receivers. Suppose, for example, in satellite communications, so these are reflex klystrons, two cavity, traveling wave, tube oscillators. They are used as embedded products in transponders design. Similarly, here, what is the local oscillators in the microwave receivers? So local are to design to construct the oscillators in the microwave receiver components. Third application, signal source in microwave generators for variable frequency. So in microwave generators are very important phenomena devices. So these microwave generators are used to generate the microwave signals for various frequencies values with the variable frequencies. What is the portable microwave links? So these are the apparatus accessories for the microwave guides. Portable microwave links. So pump oscillators in the parametrical amplifiers. So in parametrical microwave guide amplifiers, oscillators design. So oscillators designs are required for making the all these reflex klystron as a small component. Clear? So this slide indicates what is the application for the reflex klystron. So let us solve some problems on reflex klystron, which is from previous papers. So take problem number 1. So take snapshot. So a reflex klystron operates under following considerations. So what is they mentioned? V naught equals to 600 volts and LR equals to 1 mm. So did the shunt resistance RSH equals to 15 kilo ohm. So ratio of electron and mass. So we have 1.79 10 power 11. The resonant frequency they mentioned 9 giga. So this is the resonant frequency na 9 giga. So read the question. So the tube is oscillating at a resonant frequency, peak value equal to n equal to 2 mode. So we have n equal to, suppose n equal to 1, so n equal to 2, n equal to 3. Modes we already completed in mode characteristics na, n equal to 2 mode, or the 2 mode is simply call it as 1 3/4 mode. Okay. So assume transit time through gap beam loading is to be neglected. So transit time and is to be neglected. So our first assumption is our first assumption. Find the value for repeller voltage. Find the value for the repeller voltage. So we know that our direct formula, we have this direct formula. So that equals to number 1. So we have previous classes. This relation we have now. So take that one. So V naught with the formula we have. So take the formula. So V naught divided by repellor voltage plus V naught square. So that equals to electron by mass. So E by M. So already in our theory we have formula, direct formula. 8 omega square L square R, numerator 2 pi N minus pi by 2 whole square. So this is the direct formula. So already E by M they mentioned so 1 by 1.759. So that is direct substitution 1.759 10 power 11. So what is n here? And they already mentioned n equals to 2 na. So direct substitution n equals to 2. So pi by 2 is directly. So it is 8 omega. So omega equals to 2 pi f. So 8 2 pi. This is the f. So f they are given resonant frequency. So resonant frequency equals to 9 gigahertz. So L. So they mention LR 1 millimeter. So direct LR 1 millimeter. So directly you will got this value 0.832 multiplied by 10 power minus 3 by solving all this data. So from this example, what is the required thing? So what is the formula? V naught divided by so VR plus V naught square that equals to 0.832 per minus 3. Clear? So from this one, so VR plus V naught square. So what is the V naught? 600 divided by this value. So we will got 0.10 power 6. So from this already they mentioned V naught na. So we'll get VR square. So VR plus V naught equals to root of 71 power 6. So we are direct calculator solve to 50 volts. So that is the find the value of the repellor voltage. VR equals to 250 volt. So take snapshot. The second bit, the same question. The second bit, same question in the reflex klystron, same data. So find the direct current that necessary to give the microwave. Find the direct current. So what is the direct current? That is I naught. Find the direct current that is necessary to give a microwave gap voltage of 200. So in our theory, what is our formula we have? So I naught, that is the microwave direct current. Gap voltage they mentioned V2. So V2 divided by formula we have, that is V2 divided by V equal to IR na, so I equal to V by R. So that is equals to 2 J1. So Bessel coefficient, Bessel function of this one into resistance RSH. So that equals to V2 they mentioned na 200 divided by, so already they mentioned take constant J1 of X throughout our problems, 0.582 multiplied by RSH they mentioned na RSH 15 kilo 10 power 3. So automatically you will get 11.41 milliamperes. That is the way to calculate direct current. Direct current is necessary to give the microwave gap voltage. So what is the next? What is the electronic efficiency under this condition? So we have to calculate electron efficiency. Clear? So electronic efficiency. So what is the equation for electronic efficiency? So this is the efficiency equation. So 2x dash J1 of x dash, x is the bunching parameter. So it is 1.84. So x is the bunching parameter 1.84. So Bessel function for this one 0.582. Clear? Divided by what is the 2 pi n. 2 pi n minus pi by 2, direct formula. N is the oscillating mode. So we have the 2 now. So this is the 2 here. N equal to 2. So we are getting the 19.49. So very important parameter for reflex klystron for end examination efficiency. So you have to remember 2x dash J1 of x dash divided by 2 pi n minus pi by 2. So in this problem 19.48. So A bit, B bit current, direct current, C bit electronic efficiency 19.49. Take snapshot. So next problem. So the reflex klystron operates V naught equals to 1200. So what is the data, given data? V naught equals to 1200 volt. Frequency they mention. So 10 gigahertz. So value LR equals to 8 centimeters. Calculate ripple R voltage. Calculate the ripple R voltage. So to calculate the ripple R voltage, so we have so many formulas. In previous thing, we have one different one. So this is the one different one. So now in this problem, so we have using this formula. So V naught by VR plus V naught square equals to 1 by 8. This formula for solving 1 by 8 omega square L square E by M. So 2 pi n pi by 2. Clear? So entire data V naught given. So this one V are unknown. V naught 1200 1 by 8. So by solving all this omega square L square, so E by M directly given omega equal to 2 pi f. So L they mention. So here L, that is the 8 centimeters. E by M ratio of E by M 1.759. So this is the 1.75. 2 pi n. So 2 pi n equal to 2 na pi by 2 square. So by solving all this one, so answer you are able to calculate the ripple R voltage. So approximately 108 kilovolt. The 108 kilovolt. Take snapshot. Next problem number 4.